Alright, next up is Sebastian. He runs one of the coolest startups in the region. He just got back from a 3-month trip to San Francisco, where he participated in the best startup accelerator in the world, Y Combinator. Today, he will talk about how we don't need to remember any passwords anymore, or we don't need any secure passwords, because he can detect if someone hacks you, even if they know your password.
Thank you. That's a bold statement.
I like those statements.
Yeah. So I'm Sebastian. I'm the founder of Castle, as you just said. And like you said, we try to detect whether a user accounts are being hacked. And we do that by looking at individual user behavior. So like which devices they normally use, which locations they normally log in from, and etc. So in our solution, we use a great deal of anomaly detection. So I thought I'd just spend a couple of minutes talking about it because it's pretty interesting and you can use it in a range of different applications, not only for detecting hackers. So what is it? It's just about detecting something that is weird, unusual, or something that is just not normal. So in other words, it's just by finding something you don't exactly know how to look for. But it's not necessarily bad things, it can be good things as well. So how it works is that you try to define what is normal, and then what's the outlier. Can you see it? Yeah, it's this one. So for those of you who are familiar with machine learning, it's the opposite of classification. That is, when you know exactly what you're looking for, and you want to find more of that exact thing. So like a recommendation system for an e-commerce site where you have one product, you want to find similar products. Or in this case, I know exactly what this spike looks like, and I want to find more just like this. So the concept of anomaly detection is broken down into 3 steps. So like I said before, first of all, we need to find out what's normal. This can be quite tricky, as we'll see. And then next step is to measure how different is reality from what you said defined as normal. And then lastly, decide how far from normal am I willing to tolerate until I will call it an outlier or I will create an alarm for it. So let's start with a simple example. Let's say that this graph we saw before means server response time. It's your nice web app, and every once in a while someone deploys bad code and the application slows down, as we can see in this. And you want a way of detecting that. So just by looking at this graph, we can see that normal seems to be around 100 milliseconds response time. And it's pretty easy in this case also to measure the difference between our incoming response time and what we've defined as normal. So the tricky part is how do we define the threshold? Like what's the threshold for considering a response time to be anomalous or an outlier? So I guess what's so hard about this? We can just do something like this. If the value is about 200, seems about right, then we just send an alert and we're done. Yeah? That's how we do anomaly. What's so hard about it? No, so the thing is, I'm going to tell you about how can we find this threshold automatically. Like how can we don't want to hard code numbers into our application. That's never a good practice. So, turns out there is a thing. I don't know if you remember this from the math, but it's a thing called percentiles. And in an anomaly detection context, I like to see percentiles just as automatic thresholding. So this can be good to remember. So if we go back to the graph we saw before, and we look at the distribution over like what's the most requests we saw was like around 100 milliseconds. And for putting this in context with percentiles, for instance, if we look for the 99th percentile, it means that the value there, it means that like 99 out of 100 requests are faster than this particular request, if that particular request is in the 99th percentile. So it seems like this is something we can use for creating thresholds. So let's try it. So let's say we have a array of all our request times and when we start off by sorting it, takes a bit of time, and then to calculate the percentile, we need to find the index in this array that corresponds to the percentile, and then we will fetch the value at that index, and then we can use that as our alarm threshold. So now our if statement looks a bit more sensible than just a 200. But it turns out that this is pretty heavy to calculate every time for every request, and especially if we have hundreds of requests coming in every second, this array will get pretty big, and it will be pretty inefficient to calculate this on the fly. So we need a better way of calculating percentiles. So it turns out there is a better way. It's a thing called the t-digest. I won't go into detail about how it works, but it's a data structure and an algorithm for efficiently calculating percentiles. And you can remember this, but it's pretty useful for this kind of anomaly detection because it's super efficient to calculate extreme percentiles, which is exactly what we want in this case. And it's also very efficient at storing all the data, so you can store several hundreds of thousands of data points in just a few kilobytes or less. And it's very fast to look up. So if we exchange our previous code with t-digest, it will look something like this. Just create this t-digest, load the previous data, but now you simply just fetch out the alarm threshold by looking at the percentile that we're after. And then adding the new response time to the t-digest. So it will keep track of all this data for you. Good. So let's take a look at another example which is a bit more complicated. This one, normal isn't that straightforward. And the example is website traffic. So this is a hypothetical graph curve over how website traffic will look like. During the days when your customers are active on your website, you have a higher amount of traffic. During nighttime when they're sleeping, obviously they're not that active on your website. And then all of a sudden comes a spike in traffic on your website. It might be that spider that the Vanya was telling us about. So the problem is we can't use a threshold anymore. Like, where would it fit? I mean, we can't just. It will go on and off like crazy. So the thing we need to do is we need to create a model that predicts what is normal traffic. And this is a science of its own, and it really depends on the problem. You have to use a lot of your intuition around the problem. But in this case, I can just show you a simple example. Let's say that like we predict weather, the best prediction of tomorrow's weather is by looking at today's weather. So let's apply the same principle and say that traffic today will be the same as it was yesterday. And using that simple model, we can easily detect this spike in traffic. The problem is, next day we will assume that normal is having a spike in traffic, so it will generate an alert again. But never mind, this is just for illustrational purposes. So thresholding, exactly the same thing as before. We just calculate the difference between the current traffic we have and the predicted traffic from our new shiny model. And we fetch out the alert threshold by using the t-digest, and if the difference is bigger than the threshold, we send an alert. Simple. There are a lot of ways of improving this model. We can try to blend in traffic from 1 hour ago, 24 hours ago, 48 hours ago, or even like 7 days ago if we want a more slow model. And this is where it gets tricky, and this is where you need to apply a lot of your own knowledge to really figure out what's a good model. You can, for instance, use linear regression to find the coefficients for these historic data points. And there's a lot of other things you can try. But it's really fantastic because it's a lot about experimenting and testing. Because you have all the data, you can just run it and experiment and test and see what fits your model. Yeah, I think that's mostly what I wanted to tell you about. This is a brief introduction to anomaly detection, and it's basically 3 steps of that. You build a model over normal. This is often the tricky part. You measure the difference, how difference is reality from what you consider to be normal, and then you can apply this automatic thresholding with t-digest. And there's a bit of science around setting this threshold, because if you set it too high, you will risk out missing items. If you set it too low, you will create too many others, and then you would get tired of the system and you just shut it off. So there's a lot of considerations to make. But I hope I've given you some ideas on how to try this in your own products, and it's quite fun. So let me know if you find any cool use cases in this normalization, and good luck.